So we're given the original graph here, and we want to sketch the graph of y equals -1/4 f of x. So we're going to do that new graph in blue. One of the things that we notice is that our original function was f of x. I'll highlight it here. Here's our original function. Here it is in our new equation. Can we see that the -1/4 is not inside where the x is? It's outside of the function. So we can say that this part right here is going to affect the y coordinates. And it's going to affect the y coordinates in the following way. We are going to have a vertical compression by a factor of 1/4 and a reflection over the x-axis. So this would be writing it out in words. The short thing that we're going to do to actually graph it is all we're going to do is multiply each y coordinate by -1/4. So can we find some points on our original graph? Well, for sure, this point is going to be really important. 0, 0. Maybe I'll label that just above there. 0, 0 is going to be really important. And what we're going to do with our points to show our work is we're going to have our original point. We're going to draw an arrow, and above it we're going to tell what we're going to do to that point. In this case, we're going to multiply our y value by -1/4. What's going to happen to 0, 0? Nothing. Because when you multiply that y coordinate by -1/4, nothing happens. Now, I can choose a number of different points on my original graph. I could choose this one right here, this one right here, this one right there. I could choose any one of those. Why do you think I like to start with 4, 4? What's nice about 4, 4? Why wouldn't I start with the closer one, 2, 2? Yeah, you got fractions. It's not wrong to choose ones to have answers with fractions. But can you see that if I start with 4, 4, and I multiply the y coordinate by -1/4, again, my x coordinate doesn't change, but my y coordinate's going to become -1. And I stay with whole numbers, because multiplying by -1/4 is the same as dividing by a -4. And so I have a point that I could graph on my graph. What would be another easy point where you could see how it changes? -4, 4. And that would go to -4, -1. Let's just do one more. Is there another nice point? 8, 8? Sure. You multiply 8 by -1/4, you get 8, -2. So you can take a number of points and you say to yourself, I notice that what's happening in my new graph is that I'm going to have a vertical compression by 1/4 and a reflection. I can do both of those together by just multiplying my y coordinates by -1/4. And now we can mark all of those points that, oops, got to be careful here. Sometimes in the textbook, do you see what I did there when I made the dot right there? What did I do? I went over 4, down 1. That makes sense, right? But then when I look at the scale, can you see that down 1 is actually down 2? So we got to be careful with that, checking our scale there, over 8, down 2. and this is the new graph. Do you recognize the original red graph? If you had to write the actual equation in terms of x. So right now this equation is in terms of f, in terms of the function, but do you recognize what that equation is? It's the absolute value. So then if we wanted to write the equation of our blue graph in terms of x, what would it be? -1/4 absolute value of x. Number 3 is question for practice.